Hello, welcome back to Internet of Things class, and we'll be talking about Internet of Things data, cloud, and edge computing today. And in elaborating this, we will have to look at Internet of Things data generation and collection. We look at data transmission and storage, cloud computing for Internet of Things, edge and fog computing. We look at the Internet of Things data analytics fundamentals and scalability and performance management. And this will be very brief. The module will actually talk on how data generated by Internet of Things devices are collected, transmitted, processed, stored, and analyzed to produce meaningful insights and intelligent actions. And as the Internet of Things system continuously generates large volumes of data from sensors, actuators, and connected devices, effective data management and computing strategies are very important for ensuring performance, scalability, and reliability. And that is why this module will have to introduce you to the life cycle of the Internet of Things data, from generation to transmission to storage and to analysis. And by this, it shows an emphasis on the role of modern computing architecture in handling data intensive Internet of Things environment. Let's go to Internet of Things data generation and collection. And when we talk about this, it actually refers to the process through which Internet of Things devices produce, capture, and transmit data from the physical environment to digital system for analysis and decision making. And data is actually the core resource of Internet of Things system, which enables monitoring, automation, prediction, and intelligence and intelligent control access across diverse application domains. And data generation occurs when sensors detect physical changes such as temperature, motion, pressure, humidity, light, sound, or biological signals, as we've discussed before, and then converting them into digital data. And this real world data forms the foundation upon which the Internet of Things intelligence is being built, and we have the characteristics of it there. And when we talk about high volume, it's large amount from widespread devices. It's also known for rapid or often real-time generation. It's also known for structured, semi-structured, unstructured format as it pertains to variety. And also we have the temporal and spatial, which is time stamped and location specific. Data transmission and storage in Internet of Things stands as a critical processes enabling the movement of data from device to processing platform and its preservation for analysis, decision making, and long-term use. And transmission methods include device to gateway, as we've talked about, using the Bluetooth, the Zigbee, and we also have the gateway to cloud as per the broadband, the cellular, and we have the direct device to cloud communication. And the factor affecting transmission include the bandwidth, the latency, the power consumption, and the network reliability. And we also have the storage type to include the local, which is on device. We also have the cloud, which is centralized. We have the edge, which is near data source, and we have the distributed system. And key storage characteristics include scalability, durability, security, and accessibility. And it also has its challenges, which involves network congestion, storage cost, which is more data management complexity, and regulatory compliance. Looking at the cloud computing for Internet of Things, um, it actually provides the con- computational backbone which enables Internet of Things system to be able to store, process, analyze, and manage massive volume of data generated by connected devices. And through offering of scalable resources, centralized management, and on-demand service, cloud computing allows our Internet of Things solution to be able to operate efficiently without extensive local infrastructure. And we have the core cloud service model, which is in three, which is the infrastructure as a service, and another is the platform as a service, and the last one is the software as a service. And the infrastructure as a service is a virtualized computing resource, and for platform as a service, it's development platform, database, and analytics tools. And for software as a service, it is ready to use Internet of Things application via web interface. And just like we said, it has its benefits, and its role in Internet of Things includes for data storage, analytics, device management, and artificial intelligence and machine learning integration. It also has its challenges, as that's been said. And looking at the edge and fog computing, when we talk about edge and fog computing, they are distributed computing paradigm designed to complement cloud computing by bringing data processing closer to where data is generated, and they address limitations of centralized cloud system such as latency, bandwidth consumption, the real-time responsiveness, and which are critical in many Internet of Things application. And as per the edge computing, it processes data directly on Internet of Things device or nearby gateway, and it's actually characterized by low latency, reduced bandwidth, improved reliability, and enhanced privacy. And the applications that pertains to edge computing include the autonomous vehicles. They apply to autonomous vehicles, the industrial automation, and healthcare monitoring. And for fog computing, it actually introduces intermediate processing layer between edge and cloud, and it's known for its hierarchical architecture, context awareness, and mobility support. And this is applied to the likes of the smart grid, connected transportation, and smart cities. And this enables real-time autonomous response, reduce cost and congestion, and enhance reliability and privacy. For the Internet of Things data analytics fundamental, this involves the systematic examination of data generated by Internet of Things devices to extract meaningful insights, identify patterns, and support intelligent decision making. And it transforms raw sensor data into valuable information that drives automation, optimization, and predictive capability. And we have the types of data Internet of Things data analytics. We have the descriptive analytics, the diagnostic analytics. We have the predictive analytics, and we have the prescriptive analysis. And we have the key components, which includes data ingestion, processing or cleaning. We have the analysis or modeling, we have visualization or reporting. And it has a challenge also as per high volume or velocity data heterogeneity, and real-time requirements also is another challenge, and security or privacy is another. And it's actually important to unlock predictive capabilities, drive operational efficiency, create new values, and also innovations. The last part, which is scalability and performance management, it's actually a critical consideration in designing, deploying, and operating Internet of Things system as they grow in size and complexity, involving thousands of millions of interconnected devices. And we have the types of scalability, which is vertical scalability, talking about scaling up, and it is upgrading existing components like the CPU, the memory storage, and also we have the horizontal scalability, which is scaling out, that is adding more device or nodes to distribute workloads. And um, you have the performance metric there as per the latency, the throughput, the availability and reliability, and we have the energy efficiency. And in conclusion, we've been able to comprehensively understand how data forms the backbone of Internet of Things system and how modern computing architecture supports effective data processing and decision making. We've seen that Internet of Things data generation and collection create foundation for intelligent system. Also, we've seen that data transmission and storage enables real-time responsiveness and historical insights. We've seen cloud computing provides scalable, centralized resources for advanced analytics. Also, we've seen that edge and fog computing reduce latency, bandwidth usage, and enhance privacy. Also, we've seen that Internet of Things data analytics transform raw data into predictive and prescriptive insights. And we also saw scalability and performance management ensure systems grow efficiently and reliably. And lastly, integrated um, edge fog cloud architecture is seen to balance performance, cost, and intelligence. Thank you for listening.